Hi, welcome to LeetCode. So in this video, discuss LeetCode problem 2523. Closest prime numbers in range. So given two positive integers, left and right, find two integers num1 and num2 such that left less than equal to num1 less than num2 less than equal to right. So we have to find out some two number n1 and n2 which is actually within the range left and right. So this is actually the range of I can actually select n1 and n2 and both are actually distinct. That's why there is no equal to, only less than, only n1 less than n2, not equal to. So the two numbers should be distinct. Both num1 and num2 are prime numbers. Okay, so n1 n2 both are actually prime number. Okay, num1 minus num2 is the minimum amongst all other pairs satisfying the above condition. So you have to find out the minimum difference between n1 minus n2. We have to minimize this difference, right? Now we have to find out what is the minimum difference. Okay, so return the positive integer array answer, or actually return num1 and num2. Okay, so you have to return actually the n1 and n2, which actually the difference is less or the smallest. There are multiple pairs satisfying this condition. Return the one with the smallest num1 value. Okay, so suppose we got actually 10, 12. Suppose this is not actually prime. Just to explain this return output, 10 and 12, and another I got 13 and 15. Both actually difference is 2. n2 minus n1. Both actually difference is 2. So if I assume that both are all are actually prime number, let me assume that. So then the difference is 2. Then I can say that I have written this 10 and 12 because why? Because num1 here actually the less. Here num1 is 10 and here actually 13. So 10 is less than 13, so I have written 10, 10, 12. So if no such number exists, return -1 and -1. Both actually num1 and num2 both actually -1. When actually possible? So first of all, discuss when actually it is possible that both actually num1 and num2 both actually -1. Suppose we actually found out a range as 8 and 10. Suppose, so this is our range. I can actually select a number from within this range, 8, between 8 and 10. So is there any prime number between 8 and 10? So what is the number is possible? 8, 9, 10, 3 number are possible within this range. So 8 is prime? No. 9 is prime? No. 10 is prime? No. So there is no prime number. So that's why we can't actually choose any pair, valid pair. Or actually the both the numbers should be prime number, then the difference we have to find to minimize. But there are there are actually only zero number, valid zero prime numbers, empty. So that's why we have to return -1, -1. Another is possible that suppose we have our range is 7 to 10. Okay, then what actually number are possible? 7, 8, 9, 10. So 7 is prime? Yes. 8 is prime? No. 9 is prime? No. 10 is prime? No. So here only 7, only one prime number is present. Then only it is possible to get any valid pair? No. Because for a valid pair we need at least 2 number. So that's why if our prime numbers is less than 2, that time we have to return -1, -1. So this is clear. When actually return -1. Okay, so what is the brute force approach? So suppose for this example 10 and 19 were left and right is 10, right is 19. So what is the number are possible? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so first of all we have to find out what is the prime number possible within this range. Okay, so how actually check that this current number is prime or not? So the prime number, we know that the number should be divisible only with 1 and the number itself, 1 and x, whatever the number actually I have. So if there is any other number actually I can divide this number x, then this is not actually prime number. Suppose 2 is a prime number. Yes. How? Because this is only divisible by 1 and 2. 3, 1 divisible by only 1 and 3, it is not divisible by 2. 4, it is divisible by 1, also 2, also 4. So this is an extra number except 1 and 4. If there is any extra number that is except 1 and the number itself, then this is not a prime number. Got it? So we all know that about the brute force, how to check that this is actually prime number or not. So we have to check that it is divisible by 2 or not, 3 or not divisible by. So I will go up to number -1. If any one of these actually divisible, divisible by current number, then I have to return false, that this is not a prime number. At the end I have to return true if none of this actually divisible by the number. So what I have to do, I will start from our left. Left means our, this is our minimum value actually I can choose. So I'll check that these are 10 is prime or not. So for this, to check this number, this is big of n, right? To check is prime number is prime or not. So to check, because we are iterating from value from 2 to n-1 or x-1, whatever the number actually I have, 2 to here for this example 10, I have to go 2 to till 9. I have to check that any number actually can I divide this 10 with this any number within this 2 to 9. So that's why this actually the big of n time of study. Okay, so each number I need actually big of n time. So here actually you can see that for 10 I will check that this is a prime or not. So this is not prime, so I'll go to the next number 11. Okay, so this is prime, so I'll store this in a list of primes. Okay, so 11 is a prime number. Next I'll go to the 12. Okay, 12 is a prime, so it will again take big of n, and I return false that because it is divisible by 2. So 12 is not a prime number. So next is 13. 13 is a prime number. 14 not a prime number. 15 also not. 16 not. 17. So now I have to check that what is the right. Okay, 17. 18 is not a prime number. 19 is also a prime number, right? So this is a phone number, it is possible, correct? This phone number is possible, the prime number between left and right within this range. Here is left is 10 and right is 19. So within range 10 and 19 we got to these 4 prime numbers. I have to find out what is the minimum difference. Now what is the difference pair are possible? So I will check every pair, 11 and 13. Then I will 11 with 17. Then I will check with 11 with 19. Then I will check with 13 with 17. Then 13 with 19. Then 17 with 19. Okay, let me observe the pattern. Here the difference is 2. Here difference is 6. Here difference is 8. Here difference is 4. For this is 5, 6. This is actually 2. Okay, so this I know that this number actually sorted. Okay, so these two number difference, these two 11 and 13, whatever, suppose this is actually x. So and the difference between 11 and 17, y should always be greater than x. This is clear. Why? Because this is actually sorted, increasing order. So whatever the difference between 11 and 13, that will be always less than the 11 and 17, because this actually left value is fixed and right value actually shifting. So 13 minus 11 and 17 minus 11, this will be always increased. Even also 19 minus 11, so this will be also increased. So that's why I have to check only the 2 consecutive number, because this will give the minimum possible difference, correct? Minimum possible difference between 2 pair. Otherwise it will always greater than the consecutive difference. Like you can see that 11 13 the difference is 2, and 11 17 difference is 6, and 11 and 19 is difference is 8. So you can see that both are actually increasing. First it is 2, then it is 6, then it is 8. Okay, next similarly for 13 and 17. 13 and 17 the first difference is 4, then 13 and 19 the difference is 6. Got it? Both are actually increasing. So that's why I have to choose only these two pair. These two are actually our actual scope, correct? So we only consider this consecutive pair only. So here is 2. I will check only the consecutive pair, that 11 and 13 what is the difference, and similarly for 13 and 17, then 17 and 19. Clear? So now I will take the what is the minimum difference actually I have minimum difference. So after that I have to two variable, One is the difference actually I have seen, what is the minimum difference, and the current difference. Current difference. If a current difference is less than the difference, then actually this is actually one possible answer. So I'll store this. So I'll store as a as the whatever the value actually I have, prime 1, prime 0, and b as a prime 1. Next prime, 2 consecutive prime. Clear? So this brute force approach is clear. So this will take time velocity. First of all, big of n to go to from left to right. Each number I have to check that which number is actually prime or not. Then for each number to check that this actually prime or not, we need actually extract big of n. So time velocity will be big of n square. Correct? Time velocity will be big of n square. So I have to optimize this. How actually optimize this? So we all know about the Sieve of Eratosthenes, sieve approach to find the prime numbers from all the prime numbers between range, one range. So what will do? First of all, I will mark as a, all number as a prime number. Okay. So all are actually initially prime. So sieve approach is that I all know that 0, 1, 2, 3, 4, 5, 6. So I know 0 and 1 actually not a prime. So I will mark this as a, after initialize with 1, I will mark 0 and 1 explicitly as a false. This is not a prime. So I will start with 2. So I know that okay, this is a prime number. So which number actually will not be prime number again? 4, 6, 8, which actually divisible by 2. So what I will mark? I will mark 4 as false, 6 as false. In this way, I'll go to the actually 8. What is actually the consecutive? What is actually the number actually divisible by current number 2? So I will actually mark this as a false. Now I go to the next 3. This is actually prime number. Okay, so this is still 1. So this is not a prime. This is actually prime. So I will actually this is actually a prime number. Now what will be the not prime? That is divisible by 3. So which number not prime number? 6, 9, 12, 15, 18, in this way. So I will again, 6 is already marked as 0, so I do not need to do anything. I'll go to the 9, index 9, I will mark this as a 0 in this way. Got it? So ultimately, after all of this, this operation, what are actually the index is 1, that number is prime number. If it is 0, that means this is not a prime number. Got it? So now actually I have got the total prime numbers, right? Which number is prime or not? Now I know that I actually have some range left and right. So first what I will do, I will again iterate this actually big of n time velocity to mark this is a prime or not. Now within this range, I know that we have some left and right range. So from this actually the whole array, I will actually collect our valid prime numbers within this range left and right. Those are actually within this range left and right. I'll collect this. So suppose for 10 and 19 I collected actually 11, then 12, 13, 14, not 15, 16, 17 and 19. Okay, I will collect this. Which number actually 1? I will collect those number, and also within this range I'll collect this. So okay, so this is also a big of n. Got it? Now what I'll do, I will again iterate to the consecutive pair difference between two consecutive pairs. I've already explained in the brute force approach that why actually we need to do only the calculate the difference between two consecutive number. This is already sorted first of all, and it is if it is sorted, that's why we can actually take only the difference between the two consecutive pair, because our difference will be always increased. 10 and 13 and 10 and 17 it will be always increased. So that's why just take the two consecutive numbers, difference between two consecutive prime numbers. Got it? So again actually I will take that. So this will be big of n. So this is clear that how actually optimize this from big of n squared to n. So if you like the explanations, please like the video, and now go to actually code. So first of all, find the which number actually prime or not, right? So I have taken each prime vector of maximum range as right plus 1, because our index is starting from 0. So that's why we want to know the till right, because this is inclusive, right? So that's why I'm taking a right plus 1. So I know that initially that 0 and 1 is not a prime. So that's why after this initialization, I explicitly marking this as a non-prime 0. So now I'm starting from iterating from 0, I is equal to 2, and I square I into I less than equal to right, because this is our till our the maximum limit. Till actually we want to know that this is a prime or not till this value, till this number, and also I'm increasing I plus plus. Okay, so if the current index is prime, that means what? The next whatever that number divisible by this current number, that will be not a prime number. So that's why if it is current number is prime, then I'm inserting I will go into this block. So this for loop is starting from j is equal to I into 2. Why? Because 2, suppose our current number is 2, each prime 2 value will be equal to 1. This is a prime. So next number will be that is not prime, that will be 4, 6. So that's I'm starting from 2 into 2. Similarly for 3, I know that this is a prime number. So what is the next number that will be not prime? That will be 3 into 2, 6. Correct? So that's I'm starting from I into 2. And j less than equal to right. This is the maximum limit, and j plus equal to I, because this is the next number that is divisible by I. Correct? First it is 6, then 9, then 12 if our I is 3, and I will mark this as a 0. 0 means this is not a prime. So after this for loop, I will actually say that which number is a prime and which number is not a prime by using big of n. Got it? Now I want to know that which number actually within this range left and right. So that's why I've taken another vector that is storing the vector primes that actually storing the number that is within this range and also prime. So that's why I'm starting from I is equal to 2. I already know that 0 and 1 is not a prime. So that's why I'm starting from 2. I have optimized this or nothing else. And I less than equal to right. This is the maximum limit, and I plus plus. So if a current number is 1, 1 means this is a prime. And also the current number is greater than equals to left and less than equal to right. So this is our within this range, our search space, right? So I'll store this current number into the primes vector. Got it? So ultimately this prime vector to store this 11, 13, 17, 19. Correct? Now we want to know the difference between two consecutive pairs. Now before that I have actually shared the one corner case where actually we have written -1, -1. If a primes vector size is less than 2, 0 or 1, that time we don't have any actual valid pair, so that time we have to return -1, -1. So that's why I return vector as a -1, -1. Got it? If our prime vector size is less than 2, if equal to 2, that's okay, because this is a valid pair. So that's why I have taken another vector answer that I have return of size 2 and initialize with -1. Now we want to know the minimum difference. If the minimum difference, then we have to return those two prime numbers. Correct? So that's why I have taken a minimum difference variable that actually initializes the maximum into max, and I'm starting from I is equal to 0 and I less than primes, whatever the actual vector. Suppose there are actually 2 or n numbers actually, prime numbers actually have this vector actually have 4 prime numbers, right? So I have to go till which I have to compare only 11 and 13, 13 and 17, 17 and 19. So that's why I have to go only the n minus 2 or n minus 1, you can say. If there are actually 4 numbers, I have to go to only 4 minus 1. Correct? So that's why I just substitute with -1. This is clear. And now find the current diff. What are the next prime number? Primes I plus 1 and the current prime value at index I. So if a current difference is less than minimum difference that we have seen till now, because this is a global means this it is storing the ultimate minimum difference. So if the current difference is less than the difference actually we have seen till now, so this is actually the one more possible answer. So I'll store this. The answer 0 will store the current primes that is present at primes I, and answer 1 will store the primes that is present the value present at the index I plus 1. And I'll show the minimum difference, because it is possible that in future I get another pair that actually more minimum difference is minimum. So that will be our answer. So that's why I'm just also modifying this also. Okay, and return answer ultimately. Got it? I have shared this code in the description. You can check that. And also, if you're not a subscribe, please subscribe the channel. Thank you. See you in the next video.